So a 0 degrees is also 0 radians. It's just without the degree. It's a 0 radians. How many times does 30 go into 180? 6. So this is pi over 6. How many times does 45 go into 180? 4. Pi over 4. 60 into 180? 3. Pi over 3. 90 into 180? 2. Pi over 2. There's your pi. God bless you. It goes into itself once. Your 270, it goes in 1.5 times, so there's your 3 pi over 2. And then your 2 pi. Okay. Let's hit your quadrant angle. I put this little circle here because this is our unit circle. It goes 1 unit over, 1 unit up, 1 unit left. You should be able to do all of this without your calculator. Now, easiest way, and this is the way I've been doing since I was before your age, this is the x, y. It's in alphabetical order, and so is the cosine sine, cx, alphabetical order. So therefore, at the 0 degrees, or the 0 radians, whichever, the cosine is 1. The x value, see it? Cosine 1. So find the 0, cosine is 1. With me? Okay. Sine is the y value, 0. Now, the only one we have to work out is your tangent. The tangent is y over x. So 0 over 1. 0. Good. Now, the reciprocals, we can find those. We're just going to take them and turn their fractions upside down. Pretend this had a 1 over it, a 1 under it. If I flip this over, take the reciprocal, it's 1 over 0. Can I divide by 0? No. So this guy is undefined. This guy, pretend it has a 1. 1 over 1. Flip it, I get a 1. It's okay, Jenny. I didn't, but yes. And this guy, same thing. This is undefined. You can do all of these without your calculator, and you don't have to memorize them. I would rather you understand them than memorize them. Because today, we're going to kind of flip them around the circle. Okay? Let's go to the 90. Same thing here. X, y, cosine, sine. Do you guys remember also the graphs when we graph these? Do you kind of remember your sine curve going like this? Yep. So this kind of helps you visualize too where it is. There's the 0, there's the 90, the 180, the 270, the 360. We unwrap your unit circle. So at the 90, what's the sine at 90? 1. If you don't see it, stop me. Sine right here. What's the cosine? 0. Good. Now tangent is y over x. 1 over 0. Undefined. Cosecant. 1 over 1. Take its reciprocal, which is 1. Secant. 0 over 1. I'm going to flip it to 1 over 0. Undefined. Now, your tangent is 1 over 0. If I flip this over, I get 0 over 1, which is what? 0. All right, see if you guys can fill in the 180 and the 270. Take a minute and see if you can fill those in. Let's see what you have. So for the sine of 180, what's the sine of 180? Sine of 180? 0. Cosine of 180? -1. Tangent? Undefined. Y over x? 0. Right? 0. Cosecant, undefined. Secant, it's the opposite of this, so consider that over 1, -1. And cotangent, undefined. We're going to see a little pattern here. Okay. 270. What's the sine of 270? -1. What's the cosine? 0. What's the tangent? Undefined. What's the cosecant? What's the secant? Undefined. And the cotangent. See a little pattern? Okay, now your 360 is the same as your 0. So 0, 1, 0, undefined, 1, undefined. Look at the way your 90 and your 270 behave. They behave the same, right? Because look where their positions are. They're exactly the same position. 0, 1, 0, -1. They have to behave the same. And your 180 and your 360, they behave the same. Because they're in the same position where your 0 is located. So really trig is all about the patterns that you find. Okay? Now, let's hit these guys. Your 30, 60, your 45, and your 30, 60, and your 45. So I'm going to set this one up for a 30. Remember, 1, 2, they add up, radical 3. Okay? An easy way to do this, even easier, is to put this in quadrant 1. And make an information box like this. Pull your values out, and you never look back at your triangle. Your x value, radical 3. Your y value, it's parallel to your y-axis, 1. Your r, your hypotenuse, 2. Pull out your box like this. And the rest of this works really nice. I want you to get used to the x over r, y over r. Don't think opposite over adjacent. I want you to use x and y's. So your sine is y over r. 1 over 2. Good? Your cosine, x over r. X over r. Radical 3 over 2. Your tangent, y over x. 1 over radical 3. And again, we don't have to rationalize anything anymore. It's easier when you don't rationalize, because when you want to take the reciprocal, it's staring right at you. You don't have to unrationalize or think back to what it was. Now just take these and find your reciprocal functions. You can go here and do r over y, r over x, and x over y. Or you can just take what you have and take the reciprocal. So this guy is a 2. This guy is a 2 over radical 3. And this is radical 3 over 1. Don't leave the over ones. Everybody get this part? Find your pattern. Pull out your information. Isn't this much easier? Just to pull this out and never look back at your triangle. And we're going to do this no matter what quadrant your triangle goes into. If we're doing a 30 degrees reference angle, remember the bow tie we made yesterday? If we're in quadrant 2 and it's 30 degrees, we'll know that the x is negative. We'll put a negative sign by the x, and it'll figure out everything, and you don't have to calculate, like all students take calculus. You don't have to go through that. Okay? 45, 45. Let's hit your 45. I'm going to take this out of here. And I'm going to put this one up here. Here's your 45. Your sides on your 45 are 1, 1. They're the same. And one of them gets a radical. There it is, radical 2. Add them together, radical 2. So 1, 1, radical 2. Your x is 1. Your y is 1. And your R, your hypotenuse, is radical 2. So let's run through your pieces for this. Your sine, y over r. And don't rationalize, leave it like this. And your cosine, shouldn't that be the exact same, since your angles are the same? And your tangent, since the sides are the same, 1 over 1, 1. And take your reciprocals. This guy is easy. Radical 2, 1. But use this. Take it out of your triangle, put it on your quadrants, and use your x, y's, and your r's. And then your last one, I'm going to just turn this around and do a 60 on here. We'll do our own 60 rather than try to visualize it upside down. Put the 60 here. Opposite the 30 is 1. Opposite the 90 is 2. Opposite the 60 is radical 3. So this is your 1. This is your 2. This is your radical 3. X is 1. Y is radical 3. And R is 2. So what's your sine for 60? Y over R. Radical 3 over 2. What's your cosine for 60? X over R. 1/2. Your tangent, Y over X. Yep, square root of 3, radical 3. Now, let's flip these over. Take the reciprocals. 2 over radical 3. 2 and 1 over radical 3. You see a little pattern here too? Here's your cofunctions. Cofunctions are two angles that add up to 90. When your two angles, such as 30 and 60, add up to 90, the sine of 30 is equal to the cosine of 60. They're cofunctions. So you should see under 30, your sine of 30 is the same as your cosine of 60. See it? Your cosine of 30 should be the same as your sine of 60. They're cofunctions. They add up to 90. The 45s are all the same, so it doesn't pay to look at those because they're the same angle. But any two angles in your right triangle, they're next one because they add up to 90, will have cofunctions. The sine of one is equal to the cosine of the other. A nice little thing to just kind of remember. So is everybody comfortable setting this up? Okay. Now, where do we use this? We use this in a lot of different ways. Now save that because it's good to come back to that. Because like when you're doing homework and stuff, you kind of have it right there with you. You have it right at your fingertips. Okay, we started looking at your pieces yesterday. Now, let's take these angles and evaluate all your functions based on your special right triangles. These are your special right triangles. And we don't have to put them on a unit circle. The unit circle is when your radius is 1. And we found yesterday that if we put them on whatever radius you remember, we can put them on a radius of 1 as a similar triangle. Your angles are the same, they're congruent, and your sides are in proportion. So let's think what this is. 6 goes into 180 how many times? 30. So I've got a 30-degree special right triangle that I'm looking at. And what quadrant is this triangle located in? This angle. 1. It starts here, it rotates counterclockwise until it gives me a 30-degree angle. So I take this, here's my circle, I drop my triangle. And we fill in your parts. It doesn't have to be on a special right triangle. It doesn't have to be on a unit circle. So do the one you remember. Opposite the 30 is 1. Opposite the 90 is 2. Opposite the 60 is radical 3. If you want to then cut that into a unit circle, divide everything by 2. That's fine too. That works. So let's pull out your information. X is radical 3. Y is 1. Y is parallel to your y-axis. And R is 2. We're in quadrant 1, so all your functions will be positive. We make ratios. Trig is ratios. Trig ratios, we call them. So we set sine of pi over 6. Y over R. 1 over 2. Just like we did on your chart just a minute ago. Cosine of pi over 6. X over R. We did this whole line on your chart, so I'm not going to do the whole line again. But do you see what we're doing here, right? We just did this one on the chart. Okay, so in quadrant 1, we pull out the pieces, and we put everything here. Now, let's look at an angle. What 30-degree angle, okay, if this is 6, this is 6 pi over 6, this is 12 pi over 6. Remember we did this yesterday? Where would I find 5 pi over 6? What quadrant? I'm sorry? Quadrant 2. So let's put this 1 less than the 6. Remember we put these the same because they have to reduce to pi. We double these because they have to reduce to 2 pi. We're in quadrant 2. So again, it's labeled the same. So we're going to pull this out. X now is negative radical 3. Y is 1. And R is 2. We put it on your circle to help you as well. On the left side of the origin, your X is negative. Right? So anything in 2 and 3, X will be negative. Your Y's are positive on top, right? So if we're in quadrant 2, your Y is positive. If we're in quadrant 3 and 4, your Y is negative. It works off your quadrant, wherever your point is located. Technically, this is your point, your XY point. So this is your radical 3, negative radical 3, 1. That's the point on that circle. That's why we like to use your unit circle, because then your X value is the cosine. Your Y value is the sine, because there's no radius, it's 1. Now, from this, you're going to do the same exact thing. You're going to say the sine of 5 pi over 6 is equal to Y over R, 1 over 2. The cosine of 5 pi over 6 is equal to X over R, negative radical 3 over 2. It already comes out with your negative. Your tangent of 5 pi over 6 is Y over X, 1 over negative radical 3, negative 1 over radical 3. And then we can take the reciprocals of those. We can do the same thing we did in your chart. The cosecant, 2 over 1, just plain old 2. The secant, negative 2 over radical 3. The cotangent, negative radical 3. Now, do you notice the only one that's positive in quadrant 2 is your sine? And it's reciprocal? Because that's the only one that has the Y. R is always positive. Your radius has to be positive. It's a distance. It's a distance from the center of the circle to the edge of the circle. It has to be positive. So just the Y and the X are the ones that are changing on you here. Okay. Now, if I turn this around and I did a reference circle and I did a reference angle here, and this was at 30 degrees, what angle would that be in radians from here to here? If I started here and I rotated around and I stopped right there, what angle would that be? 1 less than 12, which is what? 11 pi over 6, which would be, like Carla said, 330. 330. Think radians. Okay, now, if you want everything for that, you say, set it up again. 1, 2, radical 3. Your x is radical 3. Your y is your negative. And your r is 2. And then you go through the same process all over again and do your 6 trig functions. I find this is the easiest way to do this because you don't have to worry about, oh, was my sine supposed to be positive? Was my cosine supposed to be positive? If you set this up using your reference angle of 30, set up your triangle with your special triangles, you will get this. Questions? Okay. All right, let's take a look at this guy here. Where do I find negative pi over 3? Where did the negatives go? The opposite, right? Instead of going counterclockwise, they go clockwise. And so how many times does 3 go into 180? 60. So what is my triangle going to be? 60, 30, 90. So I say, okay, opposite the 30 is 1, opposite the 90 is 2, opposite the 60 is radical 3. X is 1. Y this time down below is negative, right? And R, always positive. Can I do my whole 6 functions again? Using your y over x, your x over r, your y over x. Makes life a lot easier. Okay? Pi over 4. How many times does 4 go into 180? 45. Oh, here's my special triangle. It's a 45. I rotate it till I just open to 45. And I'll set it up 1, 1, radical 2. And from there, can you do the same thing that we just did in your chart? Right? This was quadrant 1, and we just filled this out in your chart. Now here's the difference for this guy. Again, use your patterns that we talked about yesterday. If this is a denominator of 4, this guy has to be 4 pi over 4. And what does this one have to be? 8 pi over 4. So where would I find 5 pi over 4? Quadrant 3. I got to go one past the 4, right? God bless you. Here's your part of your bow tie. Remember we looked at the bow tie? I showed you the bow tie thing? You have a 45-degree angle in every quadrant. You have a 30-degree triangle in every quadrant and a 60-degree triangle in every quadrant. So now, you set up 1, 1, radical 2. In this quadrant, x is negative. Isn't this on the negative x-axis? And isn't y negative also? And r is always positive. Oops, I left out the radical 2 over there. So, can't we go through the whole thing again and do all your functions? Okay. And this is the same as if you did all students take calculus, chemistry, whatever you decided to do. This was all positive, sine only, tangent only, and only the tangent would be positive because that's your y over x, your negative divided by a negative. And obviously it's reciprocal, it's cotangent. So you understand how we're using your special triangles? Okay, now for Monday, I want you to do the homework.